Hello and welcome everyone to our Parametric design webinar. My name is Daniel Kish. I'm the marketing and PR manager at AXISVM and Intercad. And I'm going to open this session and this webinar today. Just a few information for you. So the webinar will be recorded. So everyone is going to receive the video recording after the session. You will have the option to write in questions. Please use the chat to do so, and we'll do our best to answer the questions at the end of the webinar. I'm going to introduce our speakers really briefly, just a few sentences, and then I will hand over the mic. So our first speaker is going to be Sandra. She's working for AXISVM, and she's our expert. No one knows more about parametric design as her at our company. The next speaker is going to be ARC-S. Just sorry, I messed up the slides, but no matter. 1 second. Oh, yeah. Just a few references. So ARC-S is a Hungarian company, a innovation and technology company, consultancy firm focused on delivering innovative, sustainable, and efficient structural design solutions using state-of-the-art digital tools and engineering methodologies. The company combines technical expertise with continuous development, supporting their clients in creating economic, sustainable, and adaptable designs. Our second speaker will be Summum Engineering, and they have these references that I'm showing on the slides right now. Summum Engineering is a structural design, engineering, and optimization consultancy founded in 2017 and based in Rotterdam, Netherlands. It operates in the domains of architecture, engineering, and construction, as well as industrial design and art. Specialties include the parametric modeling and structural engineering of lightweight structures, natural building materials, complex geometries, and sustainable buildings. So that was briefly our introduction. And I'm going to hand over the mic to Sandra, who is going to kick off the presentations in just one moment. And thank you so much. Hope you will enjoy it, find it useful. Thank you.
Okay, hello. Welcome everyone to the webinar. Here you can see the contents that I'm going to talk about. First, I'm going to highlight the motivation of this event. Then I talk about parametric design in general. In the following section, I introduce the main advantages of parametric design. This block includes many fascinating and practical examples introduced by our guest speakers. And then, after a short summary, we are going to have a Q&A session, as Daniel mentioned. So let me start with the motivation of this webinar. Our company develops the AXISVM structural design and analysis software that has a powerful finite element software and practical modeling tools. We also offer optional design modules for structures consisting of reinforced concrete, steel, timber, and masonry members and their connections. Furthermore, we have modules to investigate construction stages, to perform digital wind tunnel simulations, and check the soil structure interaction. This is a very strong package, I think, but we can never be completely satisfied. We always try to find how to make it more useful and more powerful. And in this webinar, the guest presenters and me show a bunch of ideas how to extend AXISVM capabilities using the parametric design. First, let's take a look at the parametric design in general. In the traditional computer-aided design, the so-called CAD process, the user must basically know the position of the lines and surfaces right from the beginning. Every item is created by direct manipulation by hand. And almost 25 years ago, some developers started to break the limitations of the traditional CAD modeling. The generative components of Bentley was the first parametric design software for architects. It was published in 2003 and officially released in 2007. Another milestone was the release of explicit history. Nowadays, it's called Grasshopper. And this is a visual programming interface for the Rhino CAD software. This turned the design process from modeling with direct manipulation to another logic I'm going to describe now. What is parametric design? I tried to find a short and simple definition for parametric design, and I decided to explain it as programming-aided design. But don't be afraid, as programming, I do not mean the coding in Visual Studio, etc., but rather the joyful visual programming or maybe some scripting. But I could say algorithm-based design as well. The main point is that instead of directly creating and manipulating each and every item of a model, users build algorithms. An algorithm is practically a function, a collection of rules, relationships, or transformations. To create such algorithms, the parametric design software, to create such algorithms in the parametric design software, the user must have a clear design intent. And the strength of the parametric design is exactly that the intent, the purpose, is incorporated in the process and in the output itself. So the workflow looks like this: design intent, then we define parameters, some rules, and we get the design response on the output. The design intent consists of structural as well as task-specific targets. I mean, I must decide which dimensions and properties should be used as parameters. What kind of logic do I implement in the algorithm to, on one hand side, get an acceptable design response, and on the other hand, maybe to be able to reuse my script partially or fully in other similar parametric projects. If the algorithm is created, we can modify the parameters and we automatically, practically instantly get the updated design response. How is it feasible? So in the parametric design software, we create shapes with digital parameters and or with an algorithm describing geometric transformations. And thanks to the digital technology, we can modify the parameters very efficiently and conveniently, for example, by moving some sliders, and the shape is updated in the blink of an eye. What does this mean? Let me mention the valuable thoughts of Bálint Bocheim. He's a Hungarian assistant lecturer of architecture. He says that parametric design is not a new style in architecture, but rather a change in mindset. But the engineers are thinking about design in a new way, utilizing new possibilities. This new mindset and new possibilities give more space for experiments, ideas, and changes. And not just for architects, jewelry, and industrial design. And I say this because people who hear the words parametric design usually associate first on some futuristic organic shapes. The good news is that parametric design has many other advantages as well, and every engineer, so the structural engineers, can also utilize its power. Let's see the main advantages. First, the interoperability, which is the key to make parametric design widely used. Many famous companies offer parametric design solutions. You can see some examples on the slide, from Autodesk Dynamo to Graphisoft Param-O, through McNeil's Rhino Grasshopper till the Trimble SketchUp software. These systems provide platforms where user can create algorithms and visualize the design response. Furthermore, they are able to cooperate with other softwares. From this list, for example, the Rhino Grasshopper provides a very high level of interoperability. For example, and really only just some example, it can take input data from Excel, from AutoCAD. It can create and handle 3D models from Tekla, Revit, Archicad, etc. It can build and import structural analysis models from RFEM, FEMDesign, Sophistic, Constil, AXISVM. It can perform detailed calculation, again with Excel or ANSYS or IDEA, Statica, etc. AXISVM has its own connection to Rhino Grasshopper and to Dynamo from this list. And in the examples of this webinar, the GrasshopperToAXISVM add-on has been used. About the capabilities of the add-on, I'm going to say some words later on. But first, you can get an impression how to make a finite element model preparation quicker and more convenient by transforming the geometric input data into a finite element model with the aid of the parametric design software. This example is introduced by our guest speaker, D. Nagy András from Arkesh Group. And I start his session.
Hello, everyone. In practice, many design engineers experience that a significant portion of time is often spent on preparation for the actual design work, such as aligning the geometry, modeling, or lengthy preliminary calculations. Hello, everyone. In practice, many design engineers experience that a significant portion of time is often spent on preparation for the actual design work, such as aligning the geometry, modeling, or lengthy preliminary calculations. So we thought that we need some kind of workflow which is able to transform geometric data to a base finite element model. We wanted it to work without any pre-modeling from our side. Only an input as the geometry and an output of a finite element model. So what do we require exactly from the script? The script must be able to process IFC or DWG. That's the whole point of it. We wanted it to be quick and also not too demanding on the hardware as well. The generated model should be modifiable for later stages and purposes. The ability of using the model in detailed design phase is also very important. And the material quantities can also be quickly extracted. Now let me show you two examples how we used our script with AXISVM Grasshopper add-on. This first example is an RC building which has different kinds of columns, slab thicknesses, cores, and so on. So we define it with the algorithm by selecting all of them elements, and the algorithm tries to distinguish the elements based on separation method. So we actually have 3 separation methods. All of them are a bit different in terms of logic and aspect. And these separation methods distinguish elements, whether they are wall, columns, beams, or slabs. So the algorithm tries to understand not just the geometry, but also the materials, and it ultimately defines the axis model out of the DWG, which you can see here. You can see the difference between the materials, you can see the geometry, you can see all the elements which were chosen, and also it tries to understand the levels and numbering them as well, so we can have a filter on the levels. Now, what if we like to consider the cross-section in a proper slab design? We can use, let's say, rigid elements. We just turn them on, and the rigid elements will be placed according to the cross-section of the elements below and above. So you can see that every rigid element length is actually the same as the width and the height would be for the cross-sections above or below. One of the big advantages of using this workflow is that we are actually able to edit the geometry in Rhino. So whenever we feel like a certain element needs to be rescaled, modified, whatsoever, we can just do it and the whole script will follow accordingly. So in this case, I rotated this column and we can see that it's been rotated in the axis model as well. This second case is a very interesting timber building with tilt and self roof and elevation differences. This time we used a manual method for the separation, and we, after defining some very basic parameters such as the end hinges and some other stiffness, then we can generate the model without any issues.
Okay, I go back to the presentation. And on this slide, I have noted that interoperability is one of the greatest advantages of parametric design softwares. The models can be efficiently integrated into the BIM process and can be used in conceptual and detailed design phase, for analysis, even in construction or maintenance. Engineers may use the same base model for multiple purposes within seamless teamwork to avoid duplicated modeling efforts and reduce potential errors that would occur during data transfer. And this whole thing speeds up the workflow. The following topic is the flexibility. We may import or build really complex structures in AXISVM even with the traditional modeling approach. But if we have a curved structure and we need to make geometric manipulations, it can be really hard. Let me show a very simple example to feel the difference. I'm going to share 2 short videos. And in this first example, I have a flat deck in AXISVM, and I'm going to select the nodes. And with the property editor, I can translate them, for example, in Z direction with an expression just to get a curved shape. And the expression immediately disappears from the property editor as soon as the transformation is finished. If later, for any reason, I would like to change the shape, I must go back to the property editor, type a new expression from scratch to modify the shape. This is a traditional process. And then in the next video, I'm going to show how it goes in the Grasshopper environment. In contrast to the traditional solution, parametric design allows to change the geometry in an extremely flexible way. The number sliders belong to the separate input parameters, and by moving the sliders, the geometry is immediately adjusted. The algorithm fed with the inputs in the blue group describes the same expression I used in the property editor in the previous video. Since the design intent is included in this script, I do not have to give the expression in each step from scratch. And the elements can be transferred to AXISVM. This is the first version. This is flat. Then I modify it to be curved. And if I want to change it, I just type in another number or move the slider, and that's it. You already saw that the GrasshopperToAXISVM add-on can be used to transfer parametric models to AXISVM and ensures the flexibility. But I give now an overview about all other features as well. The add-on provides two-way collaboration between AXISVM and Rhino Grasshopper. it makes feasible to create complex parametric models and transfer them to AXISVM. For model building, the add-on offers a wide range of components. For example, it has access to the AXISVM material, cross-section, and CLT panel library. It can be used to define, for example, parametric cross-sections, structural members, and domains, and their connections. And the items may be grouped into custom parts as well. After support creation and load definition and meshing, the user may create steel and timber design members and start finite element analysis. This can be currently linear and nonlinear static, buckling, vibration, or seismic analysis. Then a user can perform cross-section optimization for steel and timber design members and can import some results back into Grasshopper, for example, displacements, internal forces, and stresses. The add-on can also import the main items of existing models, of existing AXS files, can extract the elements' properties, and, for example, can generate parametric loads on them. When the export and import process starts, AXISVM opens automatically and displays the structure almost immediately and updates as soon as the parameters are changed. And all these features help to benefit from the flexibility of parametric design with AXISVM. We need to be flexible because, as you know, changes always occur. In best case, they are planned. I mean, if we analyze model variants in the pre-design phase, we know that we must modify the parameters. But we are all human, so changes are needed sometimes due to mistakes. And even if you never make mistakes, I'm sure you have at least a colleague or, in worst case, a boss who does. So then the modeling and the process must also be repeated. Third scenario may be the change of requirements indicated on the customer side or by any other limitation that must be considered. With the parametric modeling, the complete process is automatically repeated. This way, the impact of these changes on the project timeline can be significantly reduced. This is why below the interoperability, I noted also the flexibility as advantage, since we can easily manage the model variants with the parametric design regardless the root cause of any required change. The following advantage is that we can automatize the workflow using parametric design. Let's see how. One meaning of the automatization is that we build a parametric model, for example, for a cell phone tower, or for any structure that has a well-defined limited parameter set. We put this effort once, and then for the further projects, in case of further customers, we can reuse the existing script partially or fully, and we can work with significantly shorter deadlines because the modeling effort is practically restricted to the adjustment of parameters, and maybe even the analysis is automatically performed for the new structure. Let's see some examples for repetitive design principles, for unconventional structures, and for the process automation from parametric modeling to the design validation. Our guest speaker, Torin Moore from Summum Engineering, is going to guide us through their parametric world. I start his presentation.
Hello everyone, my name is Torin Moore and I'm a structural engineer at the Summum Engineering Cooperative in the Netherlands. Today I'd like to take you through some of our unique projects that we engineer with the help of AXISVM and its Grasshopper plugin. Summum Engineering is an award-winning structural engineering consultancy founded in 2017 in Rotterdam. We're located in Blue City, a former tropical swimming pool that has been transformed into a circular economy hub. Summum Engineering is a worker-owned cooperative and a social enterprise. This means that the young and international team collectively determine the company's direction. Our official goal is to contribute towards a better society and environment in general, with specific focus on a sustainable built environment. Therefore, we focus on projects that tick one or more of the following 4 boxes: light, digital, natural, and circular. We work on lightweight structures such as membrane, shell, and spatial structures to minimize weight, and structures made by digital fabrication to place material where it's most effective. We also work on structures made from natural, bio-based, earthen, and low-carbon materials, and renovations of existing buildings, or new structures that reuse reclaimed materials. These are challenging projects, so our work heavily involves the use of parametric modelling to tackle these unconventional materials, geometries, and construction methods. Part of this is finite element modelling with AXISVM. We primarily use Grasshopper and AXISVM for timber structures, particularly in final design phases, where reports are needed for permit applications, and detailed design phases, where internal forces are needed for calculation of connections. AXISVM's Parametric plugin is especially useful for projects in which the geometry is complex and where design principles are repetitive. An example of the latter, repetitive design principles, is our work for Sustainer, a manufacturer of modular timber housing using prefabricated modules of laminated veneer lumber. The various configurations are imported to our parametric models for further global and detailed engineering. Although each design can vary in size, shape, and location, meaning dimensioning and connection details can differ too, the underlying principles remain the same, making it an ideal candidate for parameterization. We are working on multiple projects with emphasis on Gooi, a project in technical design stages planned to be built in Amsterdam. An example of the former is the Whale House, a timber lodge for an eco-resort in Tanzania, inspired by the whales that can be seen off the coast of Mafia Island. The structure features curved glulam arches and custom carpentry to achieve the unique design by Atli and Nomadic. AXISVM allowed for the conversion of the architect's 3D model into a structural model, the iteration of different options for its materiality, and the application of extreme wind loads due to hurricanes to the doubly curved geometry.
In the past year, Summum Engineering has been asked on 3 separate occasions to engineer a bamboo hyperboloid. With a parametric script and the AXISVM plugin, we are able to calculate the internal forces, which are then used to detail the connections of the intersections of bamboo columns. Grasshopper helps us to manage the complex hyperboloid geometry, where inputs like bamboo length and thickness, number of columns, and the radii of the openings are defined as variable parameters. Let's go through the script together, step by step. First, we define all the parameters which we use to generate the geometry. The geometry is rendered in a Rhino viewport and will update synchronously with changes to the input parameters. Next, the geometry is translated into an AXISVM model. The green components define all the line elements, including the bamboo and bolt elements. We also define the material properties and the cross-sections for each. Then we assign the loads and supports. Here the model is assembled, and with the click of a button, the geometry is sent directly to AXISVM. Once the geometry is set up, we can run the analysis directly from Grasshopper. After the analysis finishes in AXISVM, the results are sent back into Grasshopper. Since the AXISVM plugin works bidirectionally, we can both send the model and receive results. With the results imported into Grasshopper, we can check the strength of the structure according to the relevant design codes. This makes it possible to validate the design within the same workflow. As this workflow is fully parametric, the model is also synchronously updated before being transferred to AXISVM. The analysis is rerun, and the results are returned to Grasshopper. This allows for testing many iterations of the design. This workflow shows how Grasshopper and AXISVM can be used together. The combination of softwares is useful for both everyday applications, such as a truss design and parametric studies, and more complex geometries, like this hyperboloid.
After this great presentation related to the automatization, I mentioned the fact that Grasshopper not only allows us to coordinate structural design and analysis, but allows also to examine countless aspects in order to build structures that are as sustainable and as optimal as possible. Grasshopper has add-ons, for example, for shape finding and optimization, for daylight, acoustic, and wind comfort analysis to check how the building would fit best into its environment. And we can also control the material usage to keep costs in an optimal range and so on. So there are hundreds of add-ons you can use in this field. It is already automatization if we build a script and set up a parametric process. But we can go one step further and let the script automatically run and investigate more than 50,000 variants. Mokhtar Tantavi from Arkesh Group presents us a case study example for this.
If you've worked in the engineering industry before, then you probably know the pain of having to repeat multiple tasks over and over again. So what we usually do is that we try to automate the tasks in our PhD industry research. To explain the problem that we have in simple terms, this is a CLT concrete composite deck, and these two materials behave differently over time. So our goal was to understand the global behavior with so many different variables: the shrinkage of the concrete, the creep of it, the creep of the timber, and also the connection efficiency between both materials. With this much variables, it was not possible to do this manually, so we had to resort to a solution that is automated. The choice to use Grasshopper was an easy one, since we are already familiar with it in the company, and for the nature of engineering problems, it would be very beneficial to visualize the code. For the structural analysis, we decided to go with AXISVM because their components are very easy to use, and in the end, the result display is easily understood. Now to go over the code very quickly, here we have the loop part that reads information from an Excel file for different points of time, and then it feeds it into the Grasshopper code. Here in this part, we already would have defined the geometry, the number of layers for the CLT, the width, and the loads, and all the different variables that we want to define manually. And then the rest of the code is defining the geometry. It works automatically, defining the concrete segments for the link elements and the boundary conditions. It all works automatically based on what we had defined earlier. And in the end, this is the AXISVM part. It creates the meshes, it does the analysis and reads the results. Now to show you how the code works, first we launch the analysis. Model is created in Axis, and then we run the loop. We enable a component. We set the range of the information where we want the data to be read from Excel. And then you can see the analysis is running automatically, creating the loads and the meshes. Afterwards, the data is read back into the Excel file, and the graph is created automatically. Running a few thousand analyses simply wouldn't have been possible without the Grasshopper loop and the AXISVM components. Together, they saved us countless hours of manual work and gave us clear, reliable results we can build on. At Arkesh, our deep experience with CLT and CLT concrete composite technologies drives us to find feasible, economical, and innovative solutions. This mindset led us to start this research, and it's the same approach behind our Silver Smari office building in Iceland. It's a state-of-the-art hybrid structure that merges sustainability with engineering precision. Projects like SoForSmarty show how combining our expertise with AXISVM's powerful analysis tools allows us to push timber concrete technology forward.
Okay, after this presentation, the list of advantages is extended with the automatization. As we saw, the parametric scripts can cover the complete finite element workflow from model building to the import of calculation results. And this way, they save a lot of time in case of repetitive tasks. During this webinar, you have already seen fantastic structures with unconventional shape presented by our guest speakers. Last but not least, I highlight the handling of complex shapes as a separate advantage of parametric design, and I would like to show two further use cases with AXISVM for this topic. The first one is a complex load profile. In the grain silo, the horizontal pressure can be described by an exponential function. And of course, the position of the load profile, I mean the height, depends on the height of the actual filling of the silo. And this load profile can be defined as parametric fluid load. And then the load profile can be easily adjusted to any partial filling as well. And it would be, again, a horrible manual work. So once you maybe define it, but if the height must be changed, then you can start everything from scratch again. And the other example is this freeform surface structure. Because parametric design softwares offer great tools to create freeform structures. And I want to show just a dummy model starting from a cone and just moving the surfaces to create any shape we want. It's really just so simple. You select some surfaces, move them in the space, and any shape can be created, whatever the user wants. And after this dummy stuff, here is this hand shape installation model. This is created the same way in Rhino. The surfaces have been measured also in Rhino Grasshopper and transferred to AXISVM, where digital wind tunnel simulation has been performed. And you could see the wind pressure on the surfaces, now the animated horizontal streamlines, and then with the scanner display mode, you can check the pressure distribution in any arbitrary section in the space. With this, we are at the end of the presentation. Let me say a big thank you to our guest speakers from Arkesh and Summum Engineering for their high-quality presentations, which provided very impressive examples on the use of the parametric design. I think that these examples have clearly demonstrated the advantages of parametric design listed here, the interoperability, the flexibility, automatization, and handling of complex shapes. Thank you very much for your attention. We start the Q&A session, and I give back the microphone to Daniel.
Excuse us for that one. We're just in the same room, so it happens. So the first question is from Frank, who asks what properties in the Revit mode are most important to add to the model in order to cooperate with Dynamo Grasshopper. And I will ask Sandra to answer this one.
I recommend to check the guideline of our Dynamo and Grasshopper add-on, because there you can see every component, which inputs we need. But practically, as you see in the first ArcAsh video, from the geometry, you can import a lot of stuff. So there, for example, they detected what is a slab, what is a column, what is a wall, based on the dimensions. So how the edge length is related to the surface area. Yeah. So I think that's it.
Okay, thank you. Second question is from Donatas. I hope I pronounce your name correctly. Is it possible to parameterize the section of thrust members made of rectangular hollow sections together with the design of the tubular joints in AXISVM with Rhino? Good question.
Okay. I'm not sure I understand the question clearly. So you can group the items in the Grasshopper based on their properties, for example, cross sections as well. You can even highlight in AXISVM, you can create custom parts, so you can make groups out of it. You can also change cross sections or anything. And I would recommend a one-to-one discussion if this answer is not detailed enough for your questions. So if you send this question to our support channel, then we can discuss the details and help you with this.
Yeah, just one side note that we record the questions and the people who ask them, so we'll be able to reach out to you directly to give more information on the specific questions. Okay, let's have a few more questions. Gabor asks, morning, which module is required to run Rhino data exchange?
You need to download this GrasshopperToAXISVM add-on I talked about in the presentation. And you can download it from the Rhino package manager or from a website, foodforrhino.com. So you need two softwares. You need to have Rhino Grasshopper on your computer, and you have to have the AXISVM software. And the add-on that implements the connection between them is free of charge. You just have to install it and it works. And the Rhino Grasshopper software has a 90 days long trial period. And 90 days long, you can use it really for free with full functionality. And even after 90 days, you can use it, but I think the saving option doesn't work. So you cannot save your models after that. But the Rhino Grasshopper, I don't know how much does it cost currently, but if you buy it, you have a lifetime license. And then there are offers for upgrades, so then it's not so expensive. Yeah, and we can also share these links, I think. So where is this add-on available?
Yes, thank you so much, Sandra. And let's have one last question. Can you share anything about the development plans for the near future of the AXISVM software plugin. Thanks. Just to give more information, we don't need to go into details, but if you can share just one or maybe two thoughts, then I think people would appreciate it.
I think the most important information is that we would like to make steps towards the reinforcement concrete settings. So at least some components will be available in the next big published version in the v9.0. And it is also planned to make feasible some custom material definitions. And this we start to build up from the basic steps, and then we extend this possibility as well. And I think there is another question. Do we have a tutorial how to start to work with Rhino? And yes, last year we had 2 webinars, and you find them on our YouTube channel. So there you get a guidance really right from the first steps. So how to install, how to use Rhino basic functions, how to use the components, what is the logic of the add-on. So I think that with that, anyone can start work.
Great. Thank you so much. We received a lot more questions. Unfortunately, we're a few minutes overdue already. So we are going to respond to those questions directly in email later on. So no questions will remain unanswered. But just to close up the session, I would like to thank you again for our guest speakers, Arkes, Innovation and Technology, and Summum, and also Sandra, who had a really great presentation. I think all the recordings and the tutorials that Sandra mentioned will be shared in email later on, hopefully still today. If not, then tomorrow morning. So thank you again for everyone for joining. Hope you found it interesting, and see you on the next webinar. Thank you so much.
Thank you. Bye.